Okay, here's another question about a weak acid. And what's going to be the point of this question is to kind of discuss the difference between being able to make an assumption and not. Now, we have nitric acid here. It has a Ka of 4.5 times 10 to the negative fourth. It's a little bit larger than, say, acetic acid. And we're going to start off with a concentration of 0.0925 molar nitrous acid. And so I'm going to set up the ice table. I've got the ice table set up already. And so hopefully at this point you'll see how I did this. If you don't, then go back to the previous question in this problem set or on the YouTube channel, question number 6 for this chapter, and take a look and see how we set up an ice table and then the following equilibrium expression. So if I start out with 0.0925 molar, it's going to go down by X. The other concentration of H plus goes up by X, nitrite goes up by X. And then at equilibrium, I have 0.0925 minus X for nitrous acid and X for H plus and nitrite ion respectively. And so the equilibrium expression looks like this: H plus times NO2 minus over HNO2 equals the equilibrium constant, 4.5 times 10 to the negative fourth. Now, proceeding on like we did, what I get is this algebraic expression, x squared over 0.0925 minus x. Now, really, we want to be able to simplify this if it's possible, if that makes sense. So can we assume that this simplifies to this? Is x small enough to neglect? Well, in order to figure that out, we're going to have to actually solve for x and sort it out. So we get x equals 0.00645. Let's add a couple of digits so that we don't introduce any rounding errors, but remind ourselves probably 3 sig figs there are probably 2 sig figs on the final answer. So let's take a look. Seems like maybe this x is too large to just neglect. If I do the calculation, it's about 7%. It's about 7% of the number that we neglected it from. So what that means, so here's a general rule. 3% and below, that's probably okay. There's going to be this gray area between 3% and say 6, 7, 8% that you might end up with the same answer depending on sig figs. And you'll see that with the 2 sig figs that we should be using here, that you'll get the same answer. But if you used more, you wouldn't. And so what are you going to have to do? You're going to actually have to use the quadratic equation. Now, when you do this, you're going to get 2 solutions, but only one of those solutions will make sense, right? You can't have a negative concentration. And so when I do the quadratic equation and I rearrange this into the form of a quadratic equation, I get this expression. And when I use the quadratic formula, I get x equals 0.00623. Now let's compare that. Yeah, it's a little different, right? 0.00623 versus 0.00645. And if I were asking you what the concentration was, even at 2 sig figs, it's a pretty big difference. Now, I'm actually asking you what the pH is. And so the pH is 2.2055 using 0.00623. Using the other one, it was 0.1904. And so again, really, it's going to depend on what you're asking and what the sig figs are. Rounding to the 2 sig figs, I get 2.2 in either case. So there, you see we're in this gray area. So if you run across a problem like this, you're going to need to use a solver, look up a solver, use the quadratic equation. Certainly, if you're in my course, I would give you the quadratic equation on the exam. I wouldn't expect it to be memorized, although you should have a lot of practice with it at this point. Okay, that's it.